All right, go back to your notes from last class where the top of the page says a simply radical idea. And let's talk about a little bit of the vocabulary. So this right here is called the radical sign. That's the radical. The number underneath the radical is called the radicand. So R-A-D-I-C-A-N-D. Okay. And then this number right here is called the root, like the cubed root. Or it's also called the index. It tells you the root that you're taking. Now let's go to this example. When we're doing taking these roots, we can expand what's underneath out in hopes of finding, since we're taking the cubed root, finding groups of 3. And when we do that, 3, 4, 5, 6, 7, we know that we can simplify it down. So we know the cubed root of 5 times 5 times 5 is going to be 5. The cubed root of y cubed is going to be y. The cubed root of z cubed is going to be z. The cubed root of z cubed is going to be z, and we know z times z is z squared. And then everything that's left over will go back under the cubed root radical sign. So we'll have 2x squared z. This right here is your fully simplified answer in radical form. On the back page, it said there are a few ways to simplify radicals, and they depend on the following properties and concepts. You know these things, but we're just going to go over them again. So you can think about number 1, like root a times root a equals a. So you know, for example, root 3 times root 3 is going to be 3. Number 2, if we're taking the nth root of AB, that's the same as the nth root of A times the nth root of B. So if we were taking the square root of 40, we know that's the same thing as the square root of 4 times the square root of 10, or 2 root 10. For number 3, when we're dividing, so if we have the nth root of a over b, we know this is the nth root of a over the nth root of b. So if we have the square root of 25 over 16, we know it's the square root of 25 divided by the square root of 16, which equals 5/4. So let's do another example. Let's do example 4. So it was the square root of 80xy cubed. Well, the largest perfect square that goes into 80, I think, is 16. So that's 16 times 5 is 80. And then root x, and then root y cubed, it's the same thing as y squared times y. So that's the same thing as root y squared times root y. So I know this is going to be 4 root 5 root x, y, and then root y. So my final answer in simplified radical form would be 4y and then 1 square root 5xy. And this would be my final answer. Now let's do number 8. So we have 10 root 12 over 5 root 3. There's a couple of ways we can approach this. I know this is the same thing as 10 root 4 root 3 over 5 root 3. I know 5 goes into itself once and it goes into 10 twice. Root 3 goes into itself once and it goes into root 3 once. So I'm left with 2 root 4. I know the square root of 4 is 2, so 2 times 2 is 4, and 4 would be my final answer. Now let's do number 6 together. Let's go back up to number 6. Do you see how the index is the same for both of those roots? So we could write it as one radical, so the 4th root of 4t cubed times 8t squared v to the 5th. And then I can combine some similar terms there. So 4 times 8 is 32, t to the 5th, v to the 5th. I know 32 is the same thing as 2 to the 5th. So I can stretch this way out and write 2 times 2 times 2 times 2 times 2 times t times t times t times t times t times v times v times v times v times v. And now I'm looking for groups of 4. So I know the 4th root of 2 to the 4th is 2. The 4th root of t to the 4th is t. The 4th root of v to the 4th is v. And then what's left over stays under the 4th root radical, so 2tv. And this would be my final answer. Now last class I told you that the video was going to follow along with that note page I gave you. And so far the video has just been going along with the notes from last class because I wanted to supplement them and make sure everybody felt okay about simplifying radicals. The notes for day 8, when you were at your sophomore service day, was more focused on rationalizing the denominator. And that just means we can't have a radical in our denominator of our final answer. So if I had something like 3 over root 2 as my final answer, I can't have the square root in the denominator. So the way I would undo the square root of 2 would be to multiply it by the square root of 2, because I know the same root times itself is going to be the radicand, that number that's underneath the radical. But I know I'm not allowed to just multiply the denominator of a fraction by something. I would also have to multiply the numerator so that I'm in essence just multiplying this fraction by 1, because root 2 over root 2 is just 1. So now this becomes 3 root 2 over 2. And this is my final answer rationalized. Now, this fraction and this fraction are equivalent. But this is your final answer. This is your rationalized denominator. This is like having the proper grammar. This is not proper math grammar. This is the one we want. Woo, woo, woo. Now, just to go along with that, let's say I had 3 root 6 over root 5. Well, I know I can't have that root in the denominator, so I'm going to multiply by root 5 over root 5. Then this becomes 3 root 30 over 5. Is there a perfect square that goes into 30? No. 4 doesn't, 9 doesn't, 16 doesn't. So this is your final answer. Again, this fraction is equivalent to this one, but this is your proper rationalized denominator. This is the proper answer. We'll spend more time going over this in class, but I just wanted to give you a preview. I also want you to remember that your quiz is not over radicals or roots. Your quiz is over quadratic word problems, exponent properties, and the discriminant. You have great notes and handouts from class about each of these things with lots of practice problems. Remember how we have a note page on the discriminant. and we've used that in class a couple of times. And then the one with the chart on it that tells you also how many solutions and of what type at the top of the page based on whatever the discriminant is equal to. And I lost my train of thought. But you have the resources to study, but make sure you remember math is not a spectator sport. Don't just look over the quadratic word problems. Try a couple. And remember that I'll be available in tutorial on Wednesday. Okay.